Look around you. Not at the room, but at the engine running it. Every screen, every bank account, every heartbeat monitor is powered by one element, element 14. Silicon. It is the sand castle that holds up civilization. But the castle is crumbling. For 50 years, we obeyed a law, Moore's law. Every 2 years, chips get smaller, faster, and cheaper. We went from room-sized calculators to supercomputers in your pocket. But physics has a speed limit. Today's transistors are 3 nanometers wide. That is the width of a strand of DNA. If we go any smaller, the electrons don't listen anymore. It's called quantum tunneling, the leak. And the heat, it's becoming unmanageable. If silicon dies, progress stops. No better AI, no better phones. Stagnation. Scientists knew this day was coming. The hunt for a successor began decades ago. They looked at germanium, too expensive. They looked at carbon nanotubes, too hard to manufacture.
Please investigate immediately.
The answer was hiding in plain sight, in your pencil case. Graphite, pure carbon. We knew that if you could isolate a single layer, it would be a miracle material. But graphite layers are sticky. They cling together. Separating one atom layer is like trying to peel a single sheet of cling film from a roll that is 10 miles long. Enter Andrew James, a physicist with a reputation for weirdness. He once levitated a live frog just to see if he could. It was Friday night at the University of Manchester, 2004. Game and his student, Kostya Novoselov, were holding Friday night experiments. The goal: do something stupid. See what happens. James saw a piece of tape in the trash bin. It had gray residue on it. Technicians used tape to clean the graphite blocks. They threw the waste away. James pulled it out. He looked closer. He folded the tape, peeled it, folded it again. Each peel split the graphite in half. Thinner, thinner. Until only one layer remained. Graphene, the first 2D material in history. It shouldn't exist. Textbooks said 2D crystals would crumble instantly. But there it was. Stable. Perfect, they tested it. And the results broke their equipment. Stronger than diamond. Conductive as copper. Flexible as rubber. A single gram of it could cover a football field. To understand the strength, imagine an elephant. Balance that elephant on a single sharp pencil. If you stood that pencil on a sheet of graphene, it wouldn't break. But strength isn't why it replaces silicon. Speed is. In silicon, electrons bump into atoms. They create heat.
Critical temperature, friction maximized.
In graphene, the road is perfectly flat. Zero resistance. Electrons behave as if they have no mass. This is ballistic transport.
Ballistic transport trajectory confirmed. Locking sequence engaged.
It means processors 1,000 times faster than today. It means the end of heat. Your phone never gets hot again. The world of physics went insane.
Breaking news. The Nobel Prize has been awarded.
In 2010, Game and Novoselov won the Nobel Prize. They had found the God material. So, why isn't it in your phone yet? Why are we still using silicon? Because discovering it was the easy part. Making it by the ton, that is the nightmare. You cannot run a global industry on office supplies. To replace silicon, we needed to grow graphene like grass. Miles of it. The solution was chemical vapor deposition, baking methane gas until the carbon settles. It sounds simple. It is excruciatingly difficult. Graphene is one atom thick. If a single dust mote lands on it, the conductivity breaks. It becomes useless trash. For a decade, graphene was the material of the future, and it stayed there. But slowly, the recipe improved. Costs dropped from thousands to pennies. Now the floodgates are open, and the first target is energy. Batteries today are chemical slush. They charge slowly. They die. Graphene supercapacitors don't use chemistry. They use physics. Imagine charging your phone in 5 seconds. Imagine an electric car that charges faster than you can pump gas. Range anxiety becomes a thing of the past. This isn't theoretical. Graphene batteries are already entering the market. But graphene doesn't just store energy. It cleans the world. It is the ultimate sieve. A mesh so tight, only water molecules can pass. Turn the ocean into drinking water, cheaply. The global water crisis, solved by a layer of carbon. Then there is the concrete beneath your feet. Concrete production creates 8% of global carbon dioxide. It is a climate disaster. Add 0.1% graphene to the mix and the strength doubles. We can use half the concrete, half the pollution. Bridges that never rust, roads that never crack. Rust costs the global economy $5 trillion a year. Graphene paint seals the metal forever. These are the boring applications, the hidden ones. Graphene is already in your tennis racket, in your Ford car's foam. But this is just the warm-up act. The real revolution happens when we leave the ground. The space elevator. For a century, the space elevator was a fantasy, a math problem with no solution. The problem is gravity. Steel is heavy. If you built a steel cable to space, it would snap under its own weight at 5 kilometers. We need a cable that reaches 36,000 kilometers. Graphene is the only material in the known universe strong enough to hold it. A ribbon as thin as paper, climbing the gravity well.
50,000 meters. Trajectory stable. ETA 0400 Zulu.
It would cut the cost of space travel from 10,000 a pound to 10. Mars becomes a commute. The moon becomes a suburb. But graphene doesn't just go out, it goes in. Into the brain. The holy grail of biotech is the brain-computer interface, merging man and machine. But silicon chips are hard and rigid. The brain is soft and wet. They don't mix.
Critical failure imminent.
The body attacks the chip, scar tissue forms, the link dies.
Signal loss.
Graphene is soft, flexible, carbon-based, just like us. It creates a seamless link. The blind could see via camera. The paralyzed could walk via robot. We are effectively ending disability. But, before we celebrate the utopia, we have to ask the dangerous question. Every miracle material has a shadow. Asbestos was once a miracle too. Graphene is microscopic, jagged, and floats in the air. If you inhale it, does it leave? Early studies are terrifying. It acts like microscopic razor blades in the lungs.
Warning. Severe accumulation.
Manufacturing it safely is a nightmare. One leak could shut down a city. While safety regulators panic, another group is very interested. The military. They don't want batteries. They want active camouflage. Graphene can be tuned to absorb radar, to become a black hole for information. It is the ultimate invisibility cloak. Armor plates lighter than a t-shirt but stronger than Kevlar. The soldier of 2040 won't wear steel. They will wear carbon. This is the dual nature of graphene. It can save the world, or hide its destruction. But the most radical use isn't on Earth. It's in the void. Rockets are chemical explosions. They are inefficient. To reach the stars, we need to sail.
Sail deployment 95%.
A graphene solar sail is only a few atoms thick. It weighs less than a feather. Pushed by lasers, it can reach 20% the speed of light. We could reach Alpha Centauri in 20 years, not 20,000. Graphene is the only material that won't melt under the laser's heat. It is our ticket out of the solar system. The Iron Age, the Bronze Age, the Silicon Age. Historians will look back at the 2020s as the transition point. The moment we stopped building with rocks and started building with atoms. It won't happen overnight. Silicon has a 50-year head start. But the limit has been reached. The wall is here. And thanks to a roll of sticky tape, we have a way through. The future isn't made of silicon. The future is carbon. We just have to figure out how to build it. Without poisoning ourselves. Without bankrupting the economy. And without weaponizing it to extinction. It is the ultimate test of our wisdom. Can we handle the God material?
Material of tomorrow, floating here in my hand. Its potential is immense.
Only time will tell. Until then, keep peeling the tape. If you enjoy videos that go deeper than headlines and actually explain how the world works, you're in the right place. Subscribe to the channel so you don't miss the next breakdown. Hit like if this video helped you see something differently. And if you have a question or a topic you want explored next, drop it in the comments. Your curiosity drives this channel.